The zero on the vernier plate shows that the caliper has been opened past 1 inch. Then beyond 400 thousandths. Then a little beyond one more fine graduation of 25 thousandths. Adding them up, we have 1.425 inches. The first and only graduation on the vernier plate to line up with a graduation on the fixed rule is 11. In other words, the zero on the plate is 11 thousandths beyond the 1.425 line on the fixed rule. When this 11 thousandths is added, we have the final correct reading of the measured piece, 1.436 inches. The vernier principle is applied to many tools used in the machine shop and tool room. Vernier height gauges are designed to measure or mark off vertical distances from a plane surface where a high degree of accuracy is required. The vernier depth gauge is useful in gauging to close limits the depth of holes and recesses in jig, die, and fixture work. A height gauge with a special attachment may be used to measure depth of shoulders on jig work where conventional depth gauges are not adaptable. Accurate angles may be laid out or checked with a vernier bevel protractor. A fine adjustment used in combination with a vernier scale makes possible readings to a 1/12 of a degree or 5 minutes. Since the accuracy obtained by measuring between contacts depends on the ability to distinguish between graduations, there is a limit to the closeness of the markings. Therefore, the close tolerances of today's production require some method of measuring which will quickly and accurately determine these extremely close measurements. The answer to this measuring problem is the micrometer caliper, which combines the double contact of a single slide caliper with a precision screw which may be read with great accuracy. It operates on the principle that the screw, accurately made with 40 threads to the inch, will advance 1/40th of an inch with each complete turn. 1/40th of an inch is equal to 25 thousandths. Therefore, one revolution of the thimble moves the spindle of the micrometer 25 thousandths of an inch and changes the distance between the faces of the anvil and spindle by the same amount. There are 40 divisions on the sleeve, each representing one revolution of the spindle or 25 thousandths of an inch. Every fourth division is numbered, one representing 1/10 of an inch or 100 thousandths, two signifying 2/10 or 200 thousandths, three 3/10 or 300 thousandths, and so on. The beveled edge of the thimble is graduated in 25 equal divisions around its circumference. For quick reading, all lines are numbered, and 0, 5, 10, 15, and 20 are enlarged. When the anvil and spindle are closed, only the 0 line on the sleeve is visible, and the 0 graduation on the thimble aligns with the line on the sleeve. When the thimble is turned one complete revolution from 0 to 0, the anvil and spindle will open 1/40th of an inch, which is 25 thousandths of an inch. When the thimble is rotated from 0 to the first graduation, this is 1/25th of a revolution, and the anvil and spindle faces open 1/1000th of an inch. Now let's take a measurement of a piece of work and figure it out. The first number on the sleeve is visible, so we have 100 thousandths. 3 successive graduations on the sleeve are in sight, worth 25 thousandths each, so we add 75 thousandths. If we look at the thimble, we see that the third graduation lines up with the line on the sleeve, and we add 3 thousandths. Thus, the reading is 178 thousandths of an inch. An easy way to remember is to think of the various units as if you were making change. The full span of an inch micrometer is $10. Count the numbers on the sleeve as dollars, the cross lines on the sleeve as quarters, and the divisions on the thimble as cents. Add up your change and put a decimal point instead of a dollar sign in front of the figures. Modern precision production calls for still greater accuracy and closer tolerances, measurements to tenths of a thousand. To achieve these accurate readings, a vernier scale was added to the micrometer caliper, a scale which is clearly visible and easily read. There are 10 divisions marked on the sleeve which occupy the same space as 9 divisions on the edge of the thimble. When the zero graduation on the thimble lines up with the line on the sleeve, the zero graduation on the vernier scale is exactly lined up with a graduation on the thimble. The first space on the vernier scale is 1/10 less than the thimble space. 2 vernier spaces are 2/10 short of 2 thimble spaces. And number 5 is halfway between 2 graduations. Thus, the vernier scale on the sleeve divides the thousand scale on the thimble by tenths. Let's measure our workpiece with a vernier micrometer and see how it is read. The number 1 on the sleeve is visible, plus 3 graduations, giving 175 thousandths. On the thimble edge, 3 is closest to the axial line, adding 3 thousandths. Number 3 on the vernier scale lines up with a thimble graduation, adding 3 ten-thousandths. This drawing may be easier to read. The number 1 on the sleeve indicates 100 thousandths. 3 more graduations of 25,000 each gives 75 thousandths more. The third line on the thimble indicates 3 thousandths. On the vernier scale, the only graduation to a line with 1 on the thimble is the third, adding 3 ten-thousandths. And the total is 178 thousandths and 3 ten-thousandths of an inch. Correct reading to these extremely accurate limits with the micrometer caliper depends a great deal on the sense of feel. No 2 men hold a micrometer in the same way. No 2 men apply exactly the same amount of pressure to the spindle when taking a reading. A human hair looks pretty fine to the eye. The micrometer caliper shows to be only 2 thousandths of an inch in diameter. Yet, a vernier micrometer can accurately measure to the 20th part of a hair, to tenths of a thousandth of an inch. To assure greater accuracy, micrometer calipers are available with a ratchet stop or thimble friction so designed that the spindle stops turning after a given amount of pressure is applied.